Welcome everyone in hematology section of human physiology. Today we will learn about erythropoiesis. Erythropoiesis. What is erythropoiesis? Formation of erythrocytes is erythropoiesis. Hemopoiesis. What is hemopoiesis? Hemopoiesis is formation of WBC, RBC and megakaryocytes. Hemopoiesis is formation of WBC, white blood cells, red blood cells and platelets. Hemopoiesis is divided into three parts. Leukopoiesis means formation of white blood cells. Erythropoiesis, formation of red blood cells, and megakaryocytopoiesis is formation of platelets. Now today we are concerned with erythropoiesis. So by definition, erythropoiesis is formation of erythrocytes. Site of development, from where it is, from where erythrocytes develop. First is up to 3 months of early embryo, it develops from area vasculosa or mesoderm of yolk sac. This is known as mesoblastic stage, and mesoblastic stage is intravascular erythropoiesis. Now, hepatic stage, after 3 months to 6 months, erythrocytes are formed in liver and spleen. This is hepatic stage. And 6 months onwards, of 6 months of fetal life and onwards, erythrocytes develop from bone marrow. This is myeloid stage. These hepatic stage and myeloid stage are extravascular. Okay? In children, all bones have red marrow and therefore they form red blood cells, erythrocytes. In adults, only ends of long bones have red marrow and form erythrocytes. In old age, flat bones, sternum, ribs, skull form erythrocytes. These are the stages, site of development. First is mesoblastic stage, hepatic stage and myeloid stage. In adults, in emergency, in certain cases, liver and spleen, especially liver, may start forming erythrocytes. This is about the site of development. Then pluripotent stages of RBC formation, erythropoiesis. Pluripotent stem cells present in the bone marrow are divides into pluripotent stem cell present in the bone marrow divides into lymphoid stem cells and myeloid stem cells. Myeloid stem cells divide into colony forming unit, megakaryoid and erythroid, CFU-EM, and this will divide into colony forming unit, erythroid. And second colony forming unit, GM, that is granulocyte and macrophage. Today we are concerned with this colony forming unit, erythroid. This is large cell and it will divide into pro-erythroblast. Pro-erythroblast 15 to 20 macron. Then pro-erythroblast will form or divide into early normoblast, intermediate normoblast, late normoblast, reticulocyte and erythrocyte. In this, these are the stages of erythropoiesis, erythrocyte development or RBC formation. From colony forming unit, erythroid, pro-erythroblast, early normoblast, intermediate normoblast, late normoblast, reticulocyte count and erythrocyte. What happens in this development? Number 1, size of the cell decreases gradually, 15 to 20 macron in pro-erythroblast. In early normoblast, it is 14 to 16 macron. Intermediate normoblast, 10 to 16 macron. Late normoblast, 8 to 10 macron. and reticulocyte 7 to 8 micron. Erythrocyte that is matured RBC is 7.2 to 7.4 micron. Size is gradually decreasing. Then what happens to the nucleus? Nucleus is very active in this stage, and that is proerythroblast, and form excess protein so that development occurs. This is basophilic. In early normoblast also this is basophilic, and in intermediate normoblast when hemoglobin appears it becomes polychromatic, means these basophilic and eosinophilic granules are present in its cytoplasm. In late normoblast it becomes orthochromic. Hemoglobin concentration rises and it becomes more and more red. And then reticulocyte count. In reticulocyte count, reticulum, that is, this reticulum appears in the cytoplasm due to remnant of RNA. And then erythrocyte, that is mature cell. Erythrocyte, there is no nucleus, no mitochondria, no Golgi apparatus, no endoplasmic reticulum, and these erythrocytes are not capable of forming proteins. What about nucleus? Nucleus is very active at proerythroblast, early normoblast, intermediate normoblast, and it becomes cartwheel appearance. It reduces in size and activity, and in late normoblast it is very diminished in size, and in reticulocyte stage it is absorbed, or its nucleus disappears. Erythrocyte, it is not present. Then hemoglobin. Hemoglobin appears for the first time at this intermediate stage, intermediate normoblast, and increases in amount. This is about the stages of erythropoiesis. In 7 days, this erythropoiesis is completed and cell is liberated in circulation. Now, factors affecting RBC formation or erythropoiesis. First and most important factor is erythropoietin secreted from kidney. Although extrarenal sources are also there, we will learn about erythropoietin in a separate class. In a separate lecture, we will learn about erythropoietin. Erythropoietin is the most potent stimulant of erythropoiesis, and it acts at all stages of erythropoiesis, including release of reticulocyte count into the circulation. Erythrocyte release in circulation. Erythropoietin, hypoxia is the most potent stimulant of erythropoietin formation, and this is hypoxia. Effect of hypoxia on erythropoietin synthesis secretion is stimulated by thyroxine, TSH, thyroid stimulating hormone, ACTH, growth hormone, luteinizing hormone, and follicle stimulating hormone, and androgenic hormones. These hormones stimulate, increases response of cells secreting erythropoietin to hypoxia. Hypoxia influence the erythropoietin secretion, and these hormones stimulate this effect. In addition to that, proteins, vitamin C, vitamin B12, folic acid, iron, copper, zinc, calcium, cobalt, and nickel all are essential for hemoglobin formation, and these help in hemoglobin formation. Protein is essential for cell formation. Vitamin C, vitamin B12, and folic acid are essential for maturation of RBC. Factors decreasing response of hypoxia. Estrogen decreases effect of hypoxia on formation of erythropoietin. This is the factor that females have less red blood cells, less number of red blood cells, adult females. Then protein deficiency, chronic inflammatory disease, and cirrhosis of liver. These factors reduce erythropoiesis, decreases erythropoiesis. So today, just to sum up, hemopoiesis is of three types: leukopoiesis, formation of WBC; megakaryocytopoiesis is formation of platelet; and erythropoiesis is formation of red blood cell or erythrocyte. Site of development of erythropoiesis. Today we are concerned with erythropoiesis. Site of development of erythrocytes are mesoblastic stage, hepatic stage, and myeloid stage. Mesoblastic stage up to 3 months in early embryo, it develops from area vasculosa or mesoderm of yolk sac, and second is hepatic stage, liver and spleen after 3 months to 6 months, and after 6 months of fetal life from bone marrow, red bone marrow, and it is known as myeloid stage. So this is of two types: intravascular erythropoiesis in early embryo and extravascular erythropoiesis in hepatic stage and myeloid stage. Number 2, stages of development. Pluripotent stem cell present in the bone marrow is the main cell that causes formation of all types of cells, lymphoid and myeloid cell. So it divides into lymphoid stem cell and myeloid stem cell. Myeloid stem cell divide into colony forming unit, megakaryocyte and erythroid, CFU-EM, and CFU-EM will divide into colony forming unit, megakaryocyte, and colony forming unit, erythroid. Today we will learn about erythroid. Erythroid colony forming unit, erythroid is a large cell and it divides into proerythroblast, and then it will divide into early normoblast, intermediate normoblast, late normoblast, reticulocytes, and erythrocyte, mature RBC. And what happens, we have discussed, and we can see the size of the cells. Erythroid is larger than proerythroblast, somewhat reduced in size, then early normoblast, intermediate normoblast. It is reducing in size. Up to erythrocyte, it becomes 7.2 to 7.4 micron. Number 2, nucleus. Development is very active. Nucleus is very active at proerythroblast, early normoblast, intermediate. From this level, it is reducing in size. Late normoblast, it becomes cartwheel, cartwheel appearance, and it disappears in the late normoblast stage. It is not present here. And reticulocyte is a reticulum is present, that is bluish fibers are may be seen due to presence of remnants of RNA, and erythrocyte, that is no nucleus, no mitochondria, no Golgi apparatus, no endoplasmic reticulum, and they are not capable of forming any protein, cannot synthesize. And important, hemoglobin appears at intermediate stage, intermediate normoblast. Hemoglobin appears in intermediate normoblast, and it increases in amount in 2 stages. It increases in size. Up to this early normoblast, cells are basophilic. In intermediate normoblast, it becomes polychromatic, that is red and blue. Cytoplasm will contain red and blue granules. Late normoblast is orthochromic, that it becomes red, and reticulocyte count is recognized by reticulum, and erythrocyte mature cells is there. It is red due to presence of hemoglobin. What are the factors affecting this erythropoiesis? Erythropoietin is the most potent factor, which is secreted mainly from renal source and maybe to some extent from extrarenal source. And this is hypoxia is the most potent stimulant for erythropoietin secretion. And this thyroxine, thyroid stimulating hormone, ACTH, growth hormone, LH, FSH, androgenic hormone, stimulates effect of hypoxia on erythropoietin formation. Again, other factors are there: protein, vitamin C, vitamin B12, folic acid, iron, copper, zinc, calcium, cobalt, nickel, etc. are essential for hemoglobin formation. These metals are trace elements are essential for this hemoglobin formation. And vitamin B12 and folic acids are essential for maturation of RBC. Estrogen decreases sensitivity of hypoxia to produce erythropoietin and therefore reduces RBC formation or erythropoiesis. This is the main cause of decreased number of RBC in adult females. Then protein deficiency, chronic inflammatory diseases and cirrhosis of liver. All these factors reduces erythropoiesis. This is about erythropoiesis. In next class we will learn about erythropoietin or some other chapter. I think erythropoietin. In next class we will learn about erythropoietin. If you have any doubt, go into comment section and comment. I will try to solve your problem or make it detailed. You may go on my blog totalphysiology.com. You may see. Thank you. If you like it, then like it, follow and share the video. Thank you again. Thank you very much.